Hello, and welcome to Chapter 6 of our course on Artificial Intelligence and Prompt Engineering. My name is Dr. Jose Antonio Menendez. In this lesson, we will explore how to transform basic AI requests into professional, repeatable workflows using the RCCF framework. I am a systems engineer with extensive professional experience in information technology, systems implementation, business administration, cybersecurity, digital transformation, and generative artificial intelligence. Throughout my career, I have worked with organizations that needed to transform information into practical decisions, automate processes, and integrate technology into real business environments. In the previous chapters, we learned the foundations of prompt engineering. We explored how to create basic prompts, the power of few-shot prompting with examples, and how reasoning techniques can improve complex answers. We also discussed the iterative process of testing and evaluation. Today, we bring these concepts together into a unified framework for professional-grade results. We will learn how to construct professional prompts using 4 essential elements: the role the AI should perform, the context the AI needs, the constraints it must respect, and the format in which the answer should be delivered. These 4 elements, role, context, constraints, and format, can dramatically improve the relevance, consistency, usefulness, and reliability of every AI-generated response. By the end of this lesson, you will be able to transform a vague prompt like "Analyze my company" into a professional instruction such as "Act as a business process consultant specializing in textile manufacturing. Analyze the following production information. Identify the 3 most important operational risks, explain their probable causes, and present your recommendations in an executive report." This is the standard of professional AI direction. Let us begin with Section 1. Generative AI models are extremely capable, but they do not automatically know exactly what we have in mind. A common mistake is assuming the model understands the hidden context of our request. If you provide a vague input, the AI must fill in the gaps with assumptions, which often leads to generic and unusable outputs. Consider the prompt, "Write a report about cybersecurity." The AI has many unanswered questions. Is it for a small company or a multinational corporation? Should it be for technical staff or senior management? Without these details, the AI must guess. Some assumptions might be acceptable, while others could be completely different from what you intended. The second prompt provides the necessary direction. A professional prompt can be compared to a project specification. When an organization hires a consultant, they don't just say, "Do something useful." They define the objective, the scope, the available information, the expected deliverables, and the quality criteria. Prompt engineering applies this same principle to AI. The prompt becomes a compact specification describing exactly what success looks like. For this lesson, we will use a practical framework called RCCF. R stands for role, the first C stands for context, the second C stands for constraints, and F stands for format. This structure is easy to remember and can be applied across education, administration, programming, logistics, manufacturing, and finance. Let us examine each component, starting with role. A role tells the AI what perspective, expertise, or professional responsibility it should adopt. It's more than just a job title. It defines the professional lens through which the AI views the problem. This choice influences the terminology used, the factors considered, the depth of analysis, and even the tone of the final response. Consider a company with a 20% decline in sales. A financial analyst would focus on revenue trends and cash flow. A marketing strategist would look at customer segments and competitor activity. An operations consultant would focus on inventory shortages and delivery delays. The same business problem can be interpreted completely differently, depending on the assigned role. A role should be specific. Instead of saying "act as an expert," which is too general, define the role precisely. For example, act as a senior data analyst specializing in retail forecasting, or act as a Microsoft 365 security administrator responsible for identity protection. These precise definitions ensure the AI applies the correct expertise to your specific problem. Context is the background information the AI needs to complete the task correctly. In the transition to 2026, we've moved beyond simple prompting to context engineering. This involves managing the specific set of tokens, historical logs, tool outputs, and real-world data that power an agent over multi-step, long-duration tasks to ensure reasoning remains grounded. There are 5 useful types of context. Organizational context describes the environment. Task context explains what is happening and why. Audience context identifies who will read the output. Data context provides the actual information to be analyzed, and historical context explains previous actions or decisions to avoid repeating the failures of the past. When your prompt contains a large amount of context, organize it into labeled sections. This organization helps both the AI and the human user review the prompt. You can also use delimiters like triple quotation marks to distinguish your core instructions from the reference material, making it easier for the AI to navigate complex information environments. Constraints are the rules, boundaries, and limitations. They define what the AI must and must not do. They may define the response length, the tone, the language level, and the sources used. Constraints are essential because an AI response can be beautifully written and still be entirely inappropriate for your specific professional intended use. Constraints can be positive, telling the model what to do, or negative, telling it what to avoid. It is often most useful to combine both. For example, explain the subject in plain English and define every technical term the first time it appears, but do not assume that the audience has any prior programming experience. This produces much clearer results than just saying, "Don't be too technical." Prompt constraints are a primary defense against AI hallucination. By instructing the model to do not fabricate sources, or, when information is uncertain, explicitly state that it requires verification, we encourage the AI to acknowledge uncertainty rather than filling gaps with plausible-sounding but incorrect information. This ensures your AI workflows remain reliable and safe. The final component is format, which defines how the response should be organized. Common formats include paragraphs, bullet lists, tables, or structured code like JSON. The best format depends on what will happen after the AI produces the answer. If the output will be presented to executives, an executive summary is best. If it's for another software system, JSON is mandatory. Structured formats like JSON are critical when AI output is sent to another software system. However, the prompt must include specific constraints like return only valid JSON and do not include explanatory text outside the object. This is important because any additional text could cause a software integration to fail, breaking your automated workflow. We can now combine these four elements into a reusable prompt blueprint. First, define the role. Second, provide the context. Third, state the objective. Fourth, establish the constraints. And fifth, define the output format. This framework works for both simple tasks and highly advanced technical work. Let's look at some complete examples. Let's consider a human resources example. Instead of a basic prompt like create interview questions, we use the RCCF framework. We act as an HR specialist recruiting a senior data analyst, provide context about the required technical skills like SQL and Python, set an objective for a structured interview guide, and add constraints to avoid personal bias and include behavioral questions. Consider a software development task. Instead of saying, write a Python program to read a file, we define a role for a senior developer, provide context about a daily CSV file containing shipment data, and set an objective to validate records and calculate total duty. We add constraints for Python 3.12, pandas, and error logging. The prompt now describes exactly how the code should behave when problems occur. Now consider an advanced business case, AI document automation. Generative AI can help process unstructured documents like commercial invoices and bills of lading. However, a professional prompt must include strong controls. For an international logistics company, we can create an agent to extract invoice data, assign confidence scores, and flag inconsistent calculations for human review. This is a controlled business process. Confidence and validation are critical. Imagine an AI extracts an invoice value of $100,000 when the correct amount is $10,000. This error could affect customs valuation, duties, and customer billing. For high-impact workflows, every AI result should be validated against business rules. The prompt should specify these checks whenever possible to ensure accuracy. Let's look at another advanced example, AI for manufacturing. In an apparel manufacturing environment experiencing machine downtime, a specialized role prompt can identify high-value AI opportunities across the entire value chain, from spinning and weaving to quality inspection and demand forecasting. The prompt structure ensures that AI recommendations are linked to specific operational problems. A well-structured prompt is one of the foundations of an AI agent. While an AI assistant normally provides information in response to a request, an AI agent goes further by planning a sequence of steps and accessing authorized tools. In 2026, systems like OpenAI's Operator and Anthropic's computer use are navigating browser interfaces and performing real-world actions autonomously. Systems like OpenAI's Operator are Level 3 agents designed as computer-using agents. They use GPT-4o with vision to drive browsers, clicking buttons and filling forms autonomously. Meanwhile, Anthropic's Model Context Protocol, or MCP, acts as the USB-C for AI, allowing agents to securely connect to diverse data sources across different providers. This interoperability is the backbone of the Agentic ecosystem. The market for Agentic AI is projected to reach over $57 billion by 2031. However, 95% of organizations initially reported a lack of agent readiness. This ROI gap exists because many firms lack the necessary infrastructure and clean data needed for agents to perform actual labor. Bridging this gap through structured context engineering is the defining challenge of 2026. AI agents should not receive unlimited authority. A useful governance model separates actions into authorization levels, ranging from Level 1, where an agent can only read, to Level 4, where human approval is required for sensitive actions. Governance ensures that the objective is not maximum autonomy, but safe, measurable, and valuable autonomy through human-in-the-loop design. Let's try a second exercise. Email classification. Design a prompt for an email triage agent. Include categories like shipment status and billing question, and instruct the AI to determine urgency and customer sentiment. Add a constraint to never reply directly to the customer and to return the output in valid JSON. This turns a simple mailbox into an automated intelligence stream. Finally, consider personal productivity. You can transform meeting notes into a structured action plan by acting as an executive project coordinator. Extract only supported information, identify decisions and owners, and specify unassigned when a date is missing. This turns messy notes into a professional operational tool, improving clarity for the entire team. As you build these prompts, avoid common mistakes. Don't assign too many conflicting roles, like acting as a lawyer and a programmer at once. Avoid including too much irrelevant context that distracts the system, and never fail to tell the model what to do when information is missing. Review your prompt for internal conflict before using it to ensure maximum performance. To recap, assign a clear role, provide the context required to understand the situation, state the objective precisely, and define constraints that establish scope and safety. This is how we transition from simple conversation to professional specification, from isolated answers to structured workflows. This is the absolute foundation of Agentic AI. Remember, AI can generate the answer, but human beings must define the boundaries, evaluate the quality, and remain accountable for the result. For your final assignment, select one real activity from your professional life and create a complete professional prompt using the RCCF framework. Test it thoroughly and evaluate the results for accuracy and business relevance. Thank you for joining me for Chapter 6 of our AI and Prompt Engineering course. Today, we learned how structured outputs can transform a simple instruction into a professional AI workflow. In the next chapter, we will continue developing more advanced techniques for multi-agent systems and recursive self-improvement. I am Dr. Jose Antonio Menendez. Thank you for watching, and I'll see you in the next lesson.